Video 1, Introduction to Programming. Now, what are the types of programming languages? So there are three types: the procedural, functional, and the object oriented. Now, what is procedural? This type of programs contains specified structure and procedures to compose a program. Basically, all types of programming languages fall in this category. The second type is functional. Now, in this case, then the code never modify variables but create new ones as an output. When we use this, when we have to harness different sets of data from the same data set. So it is like as if we are using the same program again and again, or we are repeating the program. It was the type of the functional. The third type is the object oriented. Also around objects and their activities. It is developed to make it easier to develop, debug, reuse, and maintain the code. Two other types of classification of programming languages are static and dynamic. Now, in static, we perform type checking during the compilation of the code, and in dynamic, we perform the type checking during runtime of the code. In static, we have errors at the compile time, but in dynamic programming, we have errors at the runtime. In static programming, we declare data types before using them, and in dynamic, no need to declare before initialization. More control over the program in case of the static, and in case of the dynamic, it saves time but can show errors while running the program. There are two types of memories: stack memory and the other is the heap memory. In stack memory, we store the reference variables which may point to the objects in the heap memory, and in heap memory, we store the objects to which the reference variables are pointing. For example, if we declare a equals 20, then a is referred as the reference variable, and 20 here is the value and is referred to as object and is stored in the heap memory, and the reference variable a is stored in the stack memory. Some properties of the memory management, that is the stack memory and heap memory, is that more than one reference variables can point to the same object in the heap memory. We can have multiple reference variables in the stack memory and which then point to the same object in the heap memory. The other property is if one of the many reference variables which is pointing to the same object changes the value, then the change is visible for all the other reference variables in the stack memory. So if we have a reference variable a which is first of all have a value 20, and b which is also have a value 20, c have a value 20, and if we suppose change the value by using the reference variable b as 30, then all the other reference variable will also have the value as 30, and the last value, that is 20, is when hit by the garbage collection point is removed from the memory.